Hello, grade 7s. So we're going to start with term 2's work. I'm going to talk here in stand 2 about matter and materials. Now, just to give you a background, and if you want to follow me, you can go there in your textbook to page 60. You'll see that we're going to talk there. So as we go along, just follow me. I'm going to work on the PowerPoint, so if you want to follow me on your notes, please do so. Okay, we're going to start right away. So just to give you a background, in grade 6 we have learned about particles, and we have learned that particles are the smallest part in which we can break down a material. So in particles we have in science we have 3 phases of particles. We got solids, liquids and gases, as you can see in the pictures there. But in grade 7 we are going to actually learn that particles are also actually called atoms. Now here is a picture of an atom, and we're going to go further in this term, and I'm going to teach you exactly how atoms work and how matter and material actually consist out of particles. So I'm going to go to the next slide. You can see here, if you want to go home and see here on YouTube, I've got a link for you that you can follow. That is a video that is about the properties of materials. So the physical properties of materials. So go and watch the video there on YouTube, on this YouTube channel. Okay, I'm going to start right away. So we're going to talk about the physical properties of materials. Now, if I want to do a certain job, or I want to build a certain material or a certain thing, I need to choose for myself the exact right materials. And that is why we look at the physical properties. Now, the physical properties of a material is what I can feel, what I can see of it, what I can smell of it. So we see our world through 5 senses. And as we approach our properties, we also have physical properties of these materials. So firstly, we can see that a window, the characteristics of a window is that you can see through a window, but a window can be very brittle, not a very strong material. So that's why we put a window in a window frame. If I look, for example, to the spots on this side, we know that the physical property of metal pots is that it can actually conduct heat, and that is why I can cook my food in metal pots. The physical property of ceramic is that it can isolate heat. That's why we make coffee cups from ceramic, so that they can isolate the heat on the inside from my hands on the outside. So if I have a look here, we're going to have a look at firstly the strength. We're going to look at the strength of a material. We're going to look at the flexibility of materials. So we're going to learn about the melting and boiling points of materials and the conductivity of materials. Okay, so the physical properties is what I can feel and what I can see about this material. If I change a material physically, for example, a wooden desk, I will paint the wooden desk, or I will cut it in half, then I change it physically. If I want to change it chemically, for example, I can light it up and start a fire and the wood burn. So if I change something chemically, most of the time I can't change that material back to its original state. Okay, let us fall right away, and we're going to start with the strength of a material. So the strength of a material is determined by the amount of force that material can withstand. So I've got a picture here of diamonds for you. And if you take, for example, they say if you take a hammer and you hit a diamond, the diamond will not break. if it does break, it is not a real diamond. Okay, so diamonds are the hardest natural substance that we find on earth. That's why we take diamonds and put it in diamond rings, so that we can make sure that the diamond doesn't scratch over time. If I have it here for 60 years or 100 years, I make sure that the diamond will never scratch during that time. So that is why it makes it such a valuable material. And also, diamond is so hard that we can only cut diamonds with diamonds. Another hard material that we find in our everyday life is steel. That's why when we build a shopping mall, the frame of the whole building or of the roof will be made from steel that are put together. So steel is a very hard and very strong material that we also use. And when we go and look in our world today, we also see some concrete being used to build some bridges or buildings. And when they put the steel inside of the concrete, we call it reinforced concrete, and that makes the concrete even stronger over the years. So we've got bridges in South Africa that last almost 100 years so far, and every day there's cars going over the bridges and so forth, because it's a very strong material. The next property that we're going to have a look at is the flexibility. Now I've got a picture here of a ruler for you. Now you can see this ruler is a very flexible ruler, but obviously this ruler is not it is flexible, but I won't use the ruler to climb a mountain or be able to depend my life upon this ruler. If I climb a mountain, or I use this ruler as a safety wire. So we know that mountain climber or rock climbers, they use a material that we called that is made from nylon. Nylon is a synthetic material that was made by people. It is a very flexible material. It can go around the bends. It's very flexible, but it is also very, very strong, because these rock climbers, they risk their lives when they climb against rocks or mountain slopes. Then they use this rope to protect them from falling down and dying. So this is a very flexible but very strong. It can take up to almost 1,000 kilograms when the people are climbing the mountains. Okay, so the next property of materials that we are looking is the boiling and melting point. So it is very important when we talk about the definition of boiling point. The boiling point of a substance is the temperature in which the substance changes from a liquid to a gas. So if I have this pot, for example, you can see in this pot there is water. I've got water there, and this water is a liquid, and if I heat up the pot, eventually the water will turn into steam after it starts boiling. So the boiling point of water is 100 degrees Celsius, and that is the place where liquid turn into a gas. But on the other hand, I find the melting point. The melting point is where a substance turns from a solid into a liquid. So here I have the melting point of ice is 0 degrees Celsius, but the boiling point of water would be then 100 degrees Celsius. So make sure that you understand which point we are talking about, and it's turning the liquid into a gas or the solid into a liquid. Okay, so that's the melting and boiling point of a substance. Okay, so the next example or property that we are going to look at is the conductivity of a material. So the conductivity of a material, when we talk about this, we talk also about heat conductivity and also the ability for this material to conduct electricity. Now I can also tell you already that all metals can conduct electricity and heat, but not all metals equally well. So if I have this picture here that you see here, we can see that this materials, this inside of the wire, it's made from a metal. That makes this thing a conductor. But on the outside of the wire, we have plastic. Plastic is a very good insulator, but you would know that plastic is a non-metal. So that makes plastic a very good insulator. If I have another example of an insulator, this ceramic insulator that they use on power lines is also used as an insulator, but primarily remember that insulators are used for safety. So if I don't want to get shocked, I use an insulator on the outside of a wire. So let us just make sure that we see this conductors. Now, if I've told you that all metals are conductors of electricity and heat, but not all of them equally well. So if I have, if I can use the example, all people can run, but not all people can run equally fast. So that is the more or less the example that I want to add to you there. If we go to different materials, different metals, they conduct electricity not equally well, but they all can. Okay. So now again, I go to the metals are also very good conductors of heat. So if I use this example here, I've got a non-metal that is called polystyrene. Polystyrene is used in takeaway cups. So if I have a takeaway cup and I go to Wimpy or I go to Mug and Bean or I go to Spur and I buy myself a coffee there, I get my takeaway in this polystyrene cup. So this is a very good insulator. It insulates the heat on the inside from my hand on the outside. Another example of a good insulator of heat is this ceramic cup. Once again, we use ceramic to insulate the hot coffee on the inside from my hand that will be there on the outside. But for example, we all know if you have, for example, a spoon, a metal spoon, eventually if I leave the spoon inside of this cup, this spoon will become hot and it will eventually burn my hand. So remember now, like I've said when we talked about electricity conductivity, all metals can conduct heat and electricity, but not all metals equally well. So we can also say that also non-metals are very good conductors of insulators. Non-metals are very good insulators of heat and electricity. If we look at the three ways heat is transferred, okay. So the three ways that heat is transferred, number one, heat is transferred in solids by conduction. Now later on in this term, or in the next term, we're going to talk more in detail about conducting of or transferring of heat. But the first one, heat is transferred in a solid by conductivity. The particles, for example, there's a piece of metal and I conduct the heat conduct from one point to another point. The transfer of heat in liquids and gases are done by convection. Okay, convection is the way in which water and air, the heat is transferred in a liquid and air, in gas. Okay, and then the last one, heat is transferred in a vacuum by a radiation. Think about the sun. The sun is around about 150 million kilometers away from us, and the sun actually radiates its heat in a vacuum to the earth. Okay, but later on in next term, we're going to learn more in detail about the way heat is transferred. Okay, so if I go to the next slide, you will see here that we have done an experiment on page 63. So what we did is we took a electrical circuit, and we left an opening inside of the circuit, and we have connected all the other parts of the circuit. So what we did is we took the materials, different kinds of materials, for example like wood, and we put it inside of the open space or the gap that we left in the circuit. So if I put that material inside of the circuit will actually be closed. So if that material is a conductor, the light bulb will shine. Okay, it will light up. For example, you see here that when we took the wood, the light bulb did not light up because wood is a non-metal, so it is a good insulator of electricity. The same we did with glass, the same we did with plastic, but also when we came to the piece of copper, when we took a piece of copper and we put it inside of the circuit, the light bulb light up, and we know that copper is a metal, so that's why it is a good conductor. So the electricity was able to actually flow through the circuit. So you will see right through here that all non-metals did not light up the light bulb, but the metals did. So that is why we can make the conclusion out of this experiment that we have done that all metals are conductors of electricity, but all non-metals is insulators of electricity. We went to another experiment, and this experiment was about heat. So we took once again materials, and the only way the heat could actually come to the wax on the other side, we put some wax on the one side and we heated the material on the other side. The only way the heat could come to the wax is through the material. So once again we took the wood and we applied some heat to the wood. The wax did not melt because the wood is an insulator of heat as well, just like it is with electricity. So the wax did not melt, and the thumbnail actually stayed on the wax. In the picture you will see what we are talking about. Okay, so here once again we saw that at the copper, that is a metal, the wax did melt because copper is a very good conductor of heat, as it is also a conductor of electricity. Okay, so let us go to the next slide. The next slide we talk about other factors. Okay, so we have learned about the properties of materials. Other factors that we need to take in thought when we choose a material is we need to look at the cost. What does a material cost? What is the color of the material? What is the texture of a material? So if I use an example for the cost, we talk about the cost. Gold is the best conductor of electricity and heat that you will ever find. So in this example, we can use gold to conduct electricity and heat for us very good. But gold is too expensive for us to use. That is why we took a replacement metal in the form of copper, and that is why you will find copper on the inside of metal wires. Plastic is a very cheap and useful material, and I can find plastic in a variety of colors. If we talk about colors, I get light colors, and it's also important when we talk about colors to choose the right color. The texture, we talk about silk stockings. They are elegant, they are comfortable, but they are not very durable. They don't last very long. They tear very easily, and they tear very easily. Okay, so this is the last 3 factors that we have a look at. So I hope you have learned something today about materials and the physical properties of materials, and make sure that you pay attention as we go along and see the things further. So